Welcome. In this video, we're going to begin discussing limits, and we're going to talk about finding the limit of a function that has a domain of all real numbers. So in this situation, we're going to be considering the function f of x equals x squared, which is a polynomial. It's a parabola quadratic function. This is going to be your standard polynomial that opens up. And we know the graph of this polynomial. We know it's got several points on it, such as the origin 0, 0, or the ordered pair 1, 1, or 2, 4. All right, this function's defined everywhere. So this limit problem is more about just really understanding where the points go to. So I'm going to ask you a question. So the idea here is what happens when a number is very, very close to, say, x equals 2, but is not equal to. So it's almost equal to x equals 2, but it's not equal to. So as we are approaching x equals 2, and as we continue to learn about limits, we're going to be talking about approaching from both the left side and the right side. So we'll have left and right-handed limits and a two-sided limit, and we'll learn more about that. But really, we're just trying to understand that concept now. So what happens as x is getting infinitely close to that value of 2, but not touching 2? So the first thing we might do would be to make a table. I've brought in a table from the book, and I have blocked out some of our values here. So as I said, we're going to look as what happens as x approaches the value of 2 from the left side, as well as how x approaches 2 from the right. So from the left and the right, we are getting closer to that value of x equals 2. So you say, well, what's a number close to 2? 1.9 is close. 1.99 is closer. 1.999, 1.99999, right? We can get how close to 2? Well, the answer is we can get infinitely close to 2 because the longer string of 9s that I write out here, that's going to be closer to 2, still on the left, still a little bit less than or smaller than 2, but not exactly touching 2. So we're looking at approaching infinitely x equals 2 from the left-hand side. So what I'm going to do is I'm going to plug those values into my original function. If I plug 1.9 in, I get out 3.61. If I plug in 1.99, I get something a little bit different. Okay, well, what happens as we plug all of these numbers in? What number does it appear to be approaching? So you'll notice as we get infinitely close to 2 from the left, being slightly less in the x value, my y value appears to be getting closer and closer to 4. Now, of course, we know that 2, 4 is a point on the graph, right? And we're not saying what is happening at 2. We're saying, well, what happens as we get closer to 2 from the left, as we approach 2, and then the same approaching 2 from the right. So a number on the right of 2, which is slightly greater, might be 2.1. If we look at getting even closer to 2 on the right, 2.01, 2.001, 2.0001. So as I plug these increasingly closer to 2 values in to my original function, what are my output values? 4.41, 4.0401, 4.004001. And you see as we get down here, as x equals 2, as we got closer and closer to 2, but we're still on the right-hand side, you'll notice that this value for y, my output, is also approaching 4. So if we compare both of these close left and right side values, you'll see that it is approaching 4. So a limit isn't specifically what is the value of the function at that point. It is what is the function approaching at that point. And so I've pulled in a graph here, a nice pretty graph from the book. As we approach x equals 2 from either the right or the left, right? This is the left side. So we're approaching from the left or from the right. Where does my y value tend toward? And that we can see is that we're approaching y equals 4. So we might be able to say in this situation, and this is the new notation, we'll talk about this more, but the limit as x approaches 2 of my function, right? My function is x squared. What is that output value? The output value is 4. The limit as x approaches 2 of f of x equals 4. Or you could write that and you could say the limit as x approaches 2 of x squared equals 4. So in this case, we were just taking 2, we plug 2 in, and we get out 4. But what we'll see is that most cases that we're going to be dealing with in this class, it's not going to be readily available to always just plug that value in. 2 squared gives us 4. So how will we handle these limit problems as we get to those situations where we have undefined values, asymptotes, whatnot, holes, removable discontinuities in the graphs? So that's the idea of a limit. As x approaches what number, where does the y value tend towards? What does y approach? And so as we continue this exploration, the other thing we're going to be thinking about is that the left hand and right hand limits, they have to go to the same point in order for it to be defined. All right, so that is the end of this video. And again, we're just understanding that concept of a limit, right? And what a limit basically says is as x gets closer and closer to a number from either the left, the right, or both sides, where does that y value go? All right, I'll see you soon in the next video.